Welcome to the HyperX Academy. In this tutorial, we will guide you through the process of generating CAD stiffeners using the sizing results from HyperX. This step-by-step guide will help you understand how to efficiently utilize our tool to optimize your designs, and then export it into your preferred CAD system. On the screen, we have an example of the sizing results. This CAD entity was generated by HyperX, corresponding to the sizing optimization results. The dimensions of the stiffener match the results in the sizing window. To facilitate this process, we'll use a specialized utility within HyperX. This tool simplifies the generation of CAD geometry based on the optimization outcomes. Our utility tool provides three main options for generating stiffeners. The first option is the smeared option. This generates geometry for smeared stiffened panels where stiffener positions are not predefined. This is useful in generalized applications. The second option is the discrete option. That's suitable for panels with discrete, specifically defined stiffener positions. And the third option is the beam option, and that's designed with the HyperX beams. In this demonstration, we'll focus on the smeared option. The main inputs for the smeared option are the selection of zones and the guide curves. The selection of zones dictates where the CAD entities will be generated. Guide curves define the stiffener's path, and that's shown by the underlying yellow line on the screen. As the algorithm follows the yellow path, it uses the geometry for each zone to build the stiffener. Other settings include the types of geometry generated and various miscellaneous options, which we'll discuss later. For discrete and beam options, no guide curves are needed as the path is defined by beam or bar elements. In this example, we have zones with a hat stiffened design property and guide curves that have already been imported from a CAD system. Guide curves can be imported from various CAD systems or generated in HyperX. For this demonstration, I'll use pre-imported guide curves, but I will quickly cover how to generate our own curves inside of HyperX. First, let's use the point creation tool to drop a couple of points on our surface. Then, we will create a spline that fits between the points. Because our surface is flat, it falls well within the mesh. Next, we will define some offset curves to define our stiffener locations. From our optimization results calculated ahead of time, we know that 3.25 inches works well. Then, let's assume 3 curves on each side of the spline. Next, we will select our guide curves, zones, and click Apply. And as we can see, there are 6 equally spaced guide curves generated on our surface. However, for this demo, we used imported guide curves, so we will continue with our imported curves. Now, let's walk through the process with default settings by selecting the zones using the design property and selecting the guide curves. With the default settings applied, we see the generated geometry. Key settings include 3D cross-section type, and that allows users to choose from surface, solid, or none. The default is surface, which generates bonding surfaces around the stiffener. The other setting is the 2D profiles, and that's used as a reference in the CAD system. Multiple profiles are generated along the CAD stiffener's length as shown. You can customize settings such as solid geometry, and that generates solid bodies for import into CAD systems, and the single zone centroid, which generates a single profile for the entire zone. Further settings include mid-surface option, which is useful for creating meshes from generating CAD entities, the opposite normal option, which places stiffeners on the opposite side of the element normals, and skin offset, matching the sizing result for skin thickness, ensuring accuracy. Next, I'll demonstrate grid stiffened panel generation. For this example, we'll use a rib. This does not require guide curves, and you'll only need to select zones. For this example, we'll use the default settings to generate our grid. Generated geometry serves as a reference and doesn't follow the surface curvature. Settings include solid or surface geometry, which allows you to choose between bounding surfaces or solid bodies, include skin, which adds the skin to the model, and include fillets, which adds fillets with a specified radius to the stiffener. Finally, remember to export the generated stiffener geometry using the Export tab in HyperX. This allows you to import your optimized dimensions into your CAD system of choice. This concludes the tutorial on generating CAD stiffeners from the HyperX optimization results. Thanks for stopping by the HyperX Academy.